objective of this video is to discuss the concept of pipe networks in terms of series and parallel based on question 11.15 from the textbook. Next is to determine whether the given system in the question is class 1, class 2 or class 3. First, let's look at the first mechanism, which is series pipe network. Series pipe network comes in different diameters. Okay, the flow rate remains constant even though the velocity changes throughout the pipeline, while the total head loss is the summation of head loss from first, second and third pipe. Next is the second mechanism, which is the parallel mechanism. The flow rate is separated in 3 different pipes, and the head loss is equal in parallel pipes even though it comes in different diameters. Lastly, let's look at the series pipeline system in class 1, 2 and 3. Class 1 system is defined in terms of the size of pipes, types of minor losses present and volume flow rate of fluid in the system. For second class, it is described in terms of elevation, pipe sizes, values and fitting and allowable pressure drop in the system. For the last class, it is to find the volume flow rate in the system.
To deal with a question, first of all we need to know what classes is it. For the question 11.15, class 2 has been chosen because there are few data given, which is elaborations, pipe size, width and fittings, allowable pressure drop at key point in system. Also, the volume flow rate is also determined. The method 2B has been chosen. This is because used for the series system in which relative small minor losses exist along with a relatively large pipe friction loss. This method adds step to the process of the method 2A. Also, it requires some trials and errors to deal with the question. Bernoulli's theorem, the energy losses, volume flow rate, lastly the Reynolds number.
We have 2 parts to solve. First part is involve 4-inch pipe and the second part is 6-inch pipe. So for this diagram we have 8 energy losses. The first one is involve entrance loss, H1. The second one is elbow 90. So we have 2 elbow 90. The third one is friction, the sudden enlargement. So this is for pipe A. The second part is the part B, begins with the friction, 90 elbow, valve and the exit loss. So this is the equation. For the class 2 equation, we use this equation. Why we know that this is class 2? Because we want us to determine the volume flow rate. So we know from the notes, the equation volume flow rate is the keyword for the class 2 equation.
We are using steel pipe, not the ductile iron pipe. The roughness we can get from table 8.2 and the HL is given 10 meter. With the equation provided, we rearrange the equation to be like this and this. And for the 4-inch pipe, the fraction factor is 0.016 that can be get from table 10.5. The equation for HL is like this, including F4 and F6, V4 and V6. We are using a continuity equation, which is A1V1 equals to A2V2, and we get the answer. We simplified to get the equation to be like this. From the equation that we rearrange like just now, we rearrange back to get the equation to be like this. To find V6, we need to find the Reynolds number. This Reynolds number needs value V. V we can get from the appendix A.2. For the trial value, we use F4 equals to F6 equals to 0.2 0.02. With the new value, we substitute into the V6 and we find new V6 and V4 and new Reynolds number. So lastly, we need to find the flow rate, which is area times by velocity, and we get the answer 0.031 meter cube per second.